Hello friends, let's see this question based on forming a sequence. Quentin and Tyler are running laps on the school track. Each time they complete a lap, they do jumping jacks. They both do 0 jumping jacks after the first lap. So let me write this here. I have Quentin and Tyler. They both do 0 jumping jacks after the end of first lap. Further, each lap, Quinton adds 1 jumping jack to the number of jumping jacks he did after the lap before. So, after the first lap, he did 0 jumping jacks. Then he adds 1 to the number of jumping jacks done before. So, he adds 1 to this one. So, next time he will do 1 jumping jack. Then after the next lap he will do +1, so 2 jumping jacks, and so on, 3, 4 and so on. Let's see what Tyler is doing. Each lap Tyler adds 4 jumping jacks to the number of jumping jacks he did after the lap before. So that means Tyler is going to add 4, then 4 to this, 8, and so on, 12, and then 16, and so on. Okay, so this is the scenario. Now let's answer the questions. What is the rule? What is the rule of Quintin's numerical pattern? As you can see, Quintin's numerical pattern, we are adding 1 to it. The rule is add 1. What is the rule of Tyler's numerical pattern? As you can see, the Tyler's numerical pattern is add 4. Next. Write the first 5 terms of Quintin's numerical pattern. We have written already 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Write the first 5 terms of Tyler's numerical pattern. 0, 4, 8, 12, 16. When Quentin does 4 jumping jacks after a lap, how many jumping jacks will Tyler do after that same lap? So they are asking, when Quentin finishes 4 jumping jacks, correspondingly, what will Tyler do? How many jumping jacks will he perform? 16 laps will perform. He will perform 16. What is the relationship between the corresponding terms? Now, as you can see, there is certainly a relationship between the corresponding terms of Quentin and Tyler. So 0 is 0, 1 becomes 4, 2 becomes 8, 3 becomes 12, 4 becomes 16. You can clearly see even from here that this is 4 times. This is 4 times. So clearly this is the relationship, the corresponding relationship is times 4. 4 times, clearly. Times 4. 4. How many jumping jacks will Tyler do after the lap when Quentin does 8 jumping jacks? So if Quentin does 8 jumping jacks, how much will Tyler do correspondingly? Obviously it will be 8 times 4. So for the question number 7, I will write the answer here. 8 times 4. So 8 times 4 will be 32. What about question number 8? How many jumping jacks will Quentin do after the lap when Tyler does 40 jumps? Now this is a reverse question. If Tyler does 40, then this will be divided by 4. So 40 divided by 4 is 10. Because if you go reverse, it is divided by 4. If you come from down, it is multiplied by 4, isn't it? So I hope it's clear. So when Quentin does 8, Tyler does times 4. When Tyler does 40, Quentin will do divide by 4, so 10 jumping jacks. I hope it's clear. Let's go ahead. Use numerical patterns A and B for exercises 9 to 12. So as you can see, numerical pattern A, the rule is add 2. So the rule is very clear to add 2. Whereas in numerical pattern B, the rule is very clear to add 6. So as you can see, 2 becomes 6. So it is, the corresponding rule from here to here should be times 3. And yes, it is. So what is the rule of pattern A? Add 2. What's the rule of pattern B? Add 6. What is the relationship between them? Times 3. When the number in the pattern A is 28, so now they are saying that the number in the pattern A, when you take this series ahead, is 28, what will be the corresponding number in pattern B? So that means you have to multiply by 3. So 28 times 3. So 24 and 2, 6 and 2, 8, 84. So the answer of this is 84. This will be 84. Clear? So these patterns are very easy. You can easily write them in exam and get full marks. Alright? Let's go ahead. Complete the equation. Now this is very simple. You have a fraction where you have 5 divide 9. When you want to write it horizontally, it's obviously 5 divide by 9. Similarly, this is 13 divide by 4. 3 divide 8 in a fraction is 3 by 8. 7 divide 9 in a fraction should be 7 by 9. Now actually this fraction is ideally 7 divided by 3. So this and these are same. They both are same. So to divide this, to get this effect from the left hand side, we have to divide this also by 3, like 1 over 3, which is divided by 3. So the answer this is 1 over 3. And similarly, this is 5 divided by 4. So 5 divided by 4. That's it. This is also quite easy. Now let's solve some word problems. Aki pours the same amount of aquarium pebbles from this bag which is 7 pounds, into each of the three aquariums. What is the weight of the pebbles in each aquarium? So basically you have to divide 7 by 3. If you divide using long division, 3 times 2 is 6 and 1 is a remainder. So the question is whether you will write it as a mixed fraction or you will write it as a remainder form. Since this is weight, pounds, weight, anything which can be measured, we will write it as a mixed fraction. So we have quotient, remainder over divisor. Quotient, remainder over divisor. That is the rule. This is the quotient. This is the remainder. And this is divisor. That's the answer. Again, this is simple. 2 over 3 is 2 divided by 3. So 2 divided by 3. Easy. Spencer divides 6 pounds of food from the food drive into 3 boxes. He says each box has 3 by 6 pounds of food. Is he right? So Spencer divides 6 pounds of food from the food drive. He divides it into 3 boxes. So it is clearly 6 divided by 3. In a fraction form, it is 6 over 3. He says this is 3 by 6. No, he is wrong. Is he right? No. How do you know? Because the answer is 6 over 3 pounds. So he is wrong. Okay, understood? Let's move ahead. Which equation can match the model? Now, as you can see, the model has 3 complete blocks, which is further divided. So it is 3 divided by something. Now what? 3 divided by something. So each box, each block is divided into 5 parts. As you can see, it is divided into 5 parts. So it is something like this. 3 divided by 1 over 5. 1/5, 1/5. See, this is 1/5 and 1/5 and so on. So it is actually 3 blocks. So you have 3 blocks and you divide each block into 1/5, 1/5, 1/5. This is 3 divide 1/5. And eventually when you solve, it is keep, change, flip. The answer is 15, which is correct, which justifies, because as you can count, this is all 15, you see, 5, 5 and 5, total 15. So our answer is correct. Answer is B. 3 divide 1 over 5. Is that clear? Next, Sonia is making muffins. The recipe uses 1/2 cup of flour and makes 12 mini muffins. How many cups of flour should Sonia use to make 6 muffins? Now, for 12, they are using half cup of muffins. For 6, how much will they use? Now, as you can see, 12, the half of 12 is 6. The half of 12 is 6. So, what is the half of half? Half of half. That's the answer, half of half. Or you can also write 1/2 divide by 2. Okay, you can write it like that also if you want to understand it like that. You can put it this way, 12 divided by 2 is 6. Half divided by 2 is how much? Half divided by 2. So as you know, keep, change, flip. So 1/2 times 1/2, it is 1/4. The answer is 1/4 cup of flour. Saffron has 4 cups chocolate chips. She has a muffin recipe that calls for 1/8 cup of chocolate chips per muffin. How many muffins can Saffron make? So she has 4 cups of chocolate, and you want to divide it into 1/8, 1/8, 1/8. So it is 4 times 8, it is 32. So she can make 32 muffins with that 4 cups of chocolate chips. Mr. Klein is making vegetable soup. His recipe makes 12 servings and uses 1/3 pound of peas. How many pound of peas does he need to make 6 servings? This is exactly like this question. Exactly like this question. So 12 becomes 6 when you divide by 2. So 1/3 will become how much when you divide by 2? Let's divide. 1/3 divided by 2 will be actually 1/3 times 1/2. So it will be 1/6 pound of peas. So that's it. Alright, I'll see you in the next video with more of mathematics and easy of solution. Till then, bye bye.